Okay, guys, welcome. Today we're going to talk about linear equations, and specifically we're going to talk about linear equations in one variable. Okay, so before we get started, there are some terminology that I would like to go over, and also how we will go about solving an equation. So what we mean when we have an equation is that we have two algebraic expressions that are equal to each other. Okay, so the expression to the left of the equal sign, of course, we'll call the left-hand side of the equation, and the expression to the right of the equal sign we will refer to as the right-hand side. Okay, so the entire goal of solving an equation means you're looking for values for the variable that's in the equation that would make the equation a true statement. Okay, so once you have those values are referred to as solutions or roots of the equation, and the set of all of these solutions is called the solution set. Okay, so if you're looking at an equation, the solutions aren't going to change if you do the following operations. You're allowed to add or subtract a number or expression on both sides of the equation. You can also multiply or divide both sides of the equation by a number or expression, as long as that number is not 0, okay, because then you have a problem. So let's look at a simple example. Okay, so in part A, we have 2x plus 5 is equal to 13. Now, the goal in solving one of these is to get the variable by itself on one side. Right, now how do we get that variable by itself? Well, we basically just undo whatever is being done to the variable. So you can see on the left side of the equation, we're taking x and we're multiplying it by 2, and then we're also adding 5 to it, right? So what we want to do is we want to sort of undo these in opposite order of PEMDAS, right? So that we can get x by itself, all right? So if I go backwards, it looks like the first thing I would need to do would be to get rid of this 5, right? Because I need to undo that addition. So the opposite of adding 5 is subtracting 5, so that's what we're going to do to both sides. So if we do that, we're then left with 2x is equal to 8. So then the last step is we just need to divide both sides by 2, and I get that x is equal to 4. Of course, you can always check this by taking the original expression 2x plus 5 equals 13 and plugging in 4 for x, and see if we get a true statement. All right, so does the left side equal the right side? Well, if you do this out, we get 8 plus 5, which is 13. So you get 13 equals 13. So that answer is correct. Okay, now in part B, we have 5x plus 4x is equal to negative 18. Now here we have two variable terms which we can combine, right? If we have 5x plus 4x, we can combine that to a 9x, and I get a negative 18x, right? So since the variables were on the same side, in this case, I'm not undoing anything. I just want to sort of simplify first. Oops, so there's no x on this 18. Okay, now we just need to divide by 9, and we get that x is equal to negative 2. And of course, if you plug this back in, you should get that negative 18 equals negative 18. All right, so those are some simple examples. All right, now let's look at some other ones. Now in part A, you'll notice that we now have an x on each side, right? So in this case, we want to get all of our x terms to one side and all of our non-x terms to the other side. So we're going to move x terms to one side and non-x terms right? So of course, in this case, not that it necessarily matters, but it will be easier to move the x to the left side so that we don't have to deal with a negative, right? So if we do that, 3x minus 1x or minus x is 2x. And then I still have the minus 1 from before. My x is canceled. And on the right side, I just have 9 now. So now I can move my 1 over. And I now have that 2x after these 1's cancel is equal to 10. So now we just need to divide by 2. And we get that x is equal to 5. Okay, part B is very similar to what we just did in the previous example. We have 4x plus 7 is equal to 3. So here we can move the 7 over. And I get a 4x, these 7's will cancel, is equal to negative 4. So then divide each side by 4. And we get that x is equal to negative 1. All right, and then for part C is sort of similar to part A where we have the variable on both sides. So let's move our x over to the right side so we don't have to deal with a negative. We get negative 6 is equal to a 4x minus 26. So add 26 over. And we get that 20 is equal to 4x. So then divide both sides by 4. And we get that x is equal to 5. All right, and again, what do all these x values mean? They mean that if we plug them back into the original equation, we will get a true statement. Okay, so just keep that in mind. Okay, now these 3 examples are going to allow us to talk about how can we deal with an equation that has fractions in it. All right, now we have 2 options. One option is that we could just simply do what we did before, except we're going to be adding fractions to both sides, right? But that can usually get annoying, all right? So when you have an equation with fractions, before you do anything, we're going to get rid of the fractions, okay? So we're going to multiply both sides by the LCD to clear all the fractions out. That's going to make our life much easier. Okay, so in this case, let's see our LCD. If we have 6, 3, and 5 as our denominators, I suppose that 30 will be our best bet here, right? So our LCD in this case is 30. So we're going to multiply both sides of this thing by 30. Right, now in this case, you know, you can think of this as 30 over 1 and multiply fractions. But in slow motion, here's what's really happening, right? I'm having 30 over 1, and I'm distributing that into 5 over 6 times x. And then I'm multiplying 30 over 1 by a 4 over 3. And then that equals 3 over 5 times 30 over 1. Right, so this is sort of the slow motion version. Now, if you look at all these fractions, right, remember the original goal was to clear the fractions out. We want to get rid of these things. Now, if you look at this, you'll get nice cancellation in each one. If I do 30 divided by 6, I'm going to be left with 5. If I do 30 divided by 3, I'm going to be left with 10. If I do 30 divided by 5, I'm going to be left with 6. So now when we multiply what's left, we're going to get a 25 over 1, which is just 25. We're going to get a 40 over 1, which is just 40. And then we're going to get an 18 over 1, which is just 18. All right, so now the advantage is that you don't have fractions anymore. Okay, so now we can solve this much easier, much more easily. And we get that 25x is equal to 58. So now we just divide both sides by 25 and we get 58 over 25. Right, so we could simplify if we wanted to, or if we could, I should say, but in this case we can't. Okay, so if you have an equation with fractions, most of the time it's easiest to get rid of them first. In part B, we have negative 2/3 times x minus 5 is equal to 3 over 2 times x plus 1. Right, now once you see this, you might be tempted to distribute right away, and that's totally fine, but I also see that we have fractions there, so I want to get rid of them. All right, so I'm going to multiply both sides by this LCD, and then in this case, the LCD is 6. So I'm going to multiply this right side by 6, and also this left side by 6. All right, now you have to be careful here because you're multiplying things that are already being multiplied together, right? So you're treating the things inside these black brackets here as one term. So you're not going to distribute your 6 into all those different things there. You're just going to multiply the 6 by the fraction in each case, right? So in slow motion again, we're having the 6 over 1 times a negative 2 over 3 and then times x minus 5 is equal to 6 over 1 times 3 over 2 times x plus 1. And now we want to work on simplifying these fractions. So 6 divided by 3 would give me a 2. 6 divided by 2 would give me a 3. So I'm going to be left with a negative 4 times x minus 5 is equal to a 9 times x plus 1. Right? So now we just need to distribute, and now we can solve this as normal. So now we'll get a negative 4x plus 20 is equal to 9x plus 9. I'll move my 4x to the right side. And in the same step, I'm just going to subtract 9 over as well. So if I do that, these cancel, and so on my 9s, and it looks like I'm going to end up with an 11 is equal to 13x. So then if I divide both sides by 13, I get that x is 11 over 13. Right? So rather than dealing with all the fractional arithmetic, we can make this easier by clearing them out right away. All right, and then last but not least, part C, we have a 1/3 x plus 2 minus 3 times x over 2 plus 4 is equal to x over 4 minus 1. Okay, now in this case, because I have fraction inside of these parentheses here, I'm going to want to distribute everything first, right? So if I do that, the equation is going to be 1/3 x plus 2 minus 3x over 2 minus 12 is equal to x over 4 minus 1. Okay, now I can multiply both sides by my LCD, which in this case, if I have 3, 2, and 4, I guess our LCD will be 12, right? So let's multiply both sides by 12. All right, so moving a little faster on this example, if I do 12 divided by 3, I'll get a 4. So that becomes a 4x plus 24. And then 12 divided by 2 would give me a 6. And then times a negative 3, I'm going to get negative 18x. And then 12 times 12 is 144. And then on the right side, 12 divided by 4 gives me a 3x. And then minus 12. So on the left side, we can combine some like terms. If I do 4 minus 18, I'm going to get a negative 14x. That takes care of those two. And then if I do a 24 minus 144, that should give me a minus 120. Okay, so now we can move our x's over. So I'll add 14x. And in the same step, I'll add 12 to both sides as well. So these cancel, and so do these. And I'm going to end up with a minus 108 is equal to a 17x, right? And so I'm going to get that x is negative 108 divided by 17, which I don't believe works out nice. So if we do, let's see, if we do 6 times 17, that would give me a 60 plus a 42. So that's not going to quite get us there. So I believe that's the best we can do. All right, so that's that example. Okay. So some of these examples that we've looked at, or sorry, not some of, all of the examples that we've looked at are called first degree equations. And that's because our variable has only occurred to the first power, right? And most of the time we're going to refer to these as linear equations, right? So in general, you can always write a linear equation in the form ax plus b, of course, is equal to 0. And this is something that we're going to discuss in much more detail a little later on in the course, right? But that's just something I want to bring to your attention. Now, the last thing that we're going to discuss in this video is different types of equations, right? Now, so far, all of the equations that we've looked at have been conditional equations, right? So a conditional equation is only going to be true for certain values of x, right? So in each of the ones that we've done, we've found that x is equal to some number, and it's only true for that number, right? So that means that it's a conditional equation, all right? But there are other types of equations that can come up. One of those types is what's called an identity, right? And an equation is true for any value of x is what's called an identity. And this is going to happen when you end up with something like 4 is equal to 4, right? All of your x's cancel out, and you're going to get a true statement as a result, right? So that would be an example of an identity. Now, an example of no solution is where something happens like 4 is equal to 3, right? So this is obviously not true, and your x's have all canceled out, so your value of x won't change that fact, right? So that's where you get the no solution case. So I want to run through a couple examples of that before we wrap this video up. So in part A, you have 4 times x minus 1 is equal to 3x minus 1. So if we solve this, we're going to get 4x minus 4 on this side. And then if I move my 3x over and add my 4 over, these cancel, and so will these, and I'm going to get an x right away is equal to 3. So since I get one single answer, that's a conditional equation. All right, in part B, we have 5 times x plus 2 plus x is equal to 6x plus 10. So if I solve this, I would need to distribute, and I get a 5x plus 10 plus x equals 6x plus 10. And then I can combine my 6x and x on the left side and get a 6x plus 10. Right? Now, at this point, you can already see that you have the same thing on both sides, right? But if you were to even try to get x by itself, as soon as you subtract 6x from one side, it also cancels on the other side. So you get 10 is equal to 10, right? So of course this is true, so we would say that this is an identity. And most of the time we say that x can be any real number. Or there are infinite solutions, right? Something like that. All right, in part C, we have 4 times x minus 3 is equal to 4x minus 3. So if we distribute, we get a 4x minus 12 equals 4x minus 3. Now here, when you subtract your 4x's, of course, they're both going to cancel on each side. But now you're left with negative 12 is equal to negative 3, right? So this is, of course, not true. So this is where you have no solution, right? No matter what you make your x value here, you're never going to get a true statement to come out. Okay, moving on to part D, we have a negative 2 times an x minus 5 plus 2 is equal to negative 2 times x minus 6. So now if we distribute, we get a negative 2x plus 10 plus 2 is equal to negative 2x plus 12. Right? So now, of course, you can combine the 10 and the 2 and you get a 12. Of course, you see you get the same thing on both sides. So once you once you add 2x to both sides, you're going to be left with 12 equals 12. So this, of course, is another identity. And of course, it's true for infinitely many values of x, or infinitely many solutions. Okay, part E, we have 3 times 2x plus 1 is equal to negative 4 times x plus 1 plus 10x. Okay, so if we distribute here, we're going to get a 6x plus 3 is equal to negative 4x minus 4 plus 10x. And of course, on the right side, we can combine the 10x and the negative 4x to give a 6x. And of course, here, once we cancel our 6x's from both sides, we get a 3 equals negative 4. So this is no solution. Right, and last but not least, part F, we have negative 5 times x minus 2 is equal to 2x plus 17. So if we distribute on the left side, we get a negative 5x plus 10 is equal to 2x plus 17. I can add my 5x to both sides and subtract 17. And then I'll be left with a negative 7 on the left side and a 7x on the right side. So it looks like once I divide, I get x is equal to negative 1. So since I get a single value, this is a conditional equation. All right, so that concludes this video on linear equations in one variable. Hope you enjoyed, and I will see you next time.